Pre-statistics. Graphing exponential functions. Lesson objectives. Sketch the graph of an exponential function by hand and using a graphing calculator. Explain how the values of a and b affect the graph of f of x equals a times b to the x power. 3. State the base multiplier property, the increasing or decreasing property, and the reflection property. All of these properties deal with the graph of this exponential function. Lesson objective. Example 1. Graphing exponential functions with b greater than 1. Example 1. Graph f of x equals 2x by hand. Solution? Well, we first want to pick some inputs, put those values into the equation, and find the outputs. So when x is a -3, we have 2 raised to the -3 power, which becomes 1/8. For -2, we have 1/4. -1 is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And we have our table of values here. And as we see, as x increases by 1, the values for the output multiply by 2. They double. Plotting these points, we have this graph. So this is the graph of f of x equals 2 to the x power. B is 2, and we call this an exponential growth. To verify this using a graphing calculator, we type in the equation in y1. If we hit window, we have x min to be -4 to 4, and then y min to be 0 to 8. We get the following graph. So these look the same. Now, using this graph, we can answer some questions like, what is the domain and range of this function? So what is the domain means what are the values of x that have a spot on this graph. And if you think about it, this is going forever in the negative direction, and this is going to infinity in the positive direction. So the domain is all real numbers. We can write all real numbers as from negative infinity to positive infinity. The range, what are the possible y values? Well, if we look closely, this line is approaching y equals 0, but it's not touching. And also, any negative y values do not have a spot on this graph. So the range would be all positive y values. One way we can write that is parenthesis 0, comma, to positive infinity. Where is this function increasing? This function is increasing everywhere. As x gets bigger, y gets bigger. This is all real numbers. Where is the function decreasing? Decreasing means as x gets larger, y gets smaller, or as x gets smaller, y gets larger. And this is nowhere. This is what we call a strictly increasing function. Where is the function positive? So that's asking where are the y values, the outputs, positive. And as we can see, this graph covers quadrants 1 and 2, quadrants 3 and 4, where y's are negative. There's no part of the graph in these quadrants. So the function is positive for all real numbers, and the function is negative nowhere. It's the empty set. Let's look at another example. This time we're going to have b be in between 0 and 1. So example 2, graph g of x equals 4 times 1/2 to the x power. So our base is 1/2. 1/2 is in between 0 and 1. Let's see by changing the base, how does that affect the graph? Solution: we construct a table of values. So, for example, if we use -1, g of -1 would be 4 times 1/2 to the -1 power. 1/2 to the -1 power becomes 2, and 4 times 2 is 8. So when x is -1, y is 8. As you'll see on the table in the next slide, as x increases by 1, y is multiplied by 1/2. So as x increases by 1, the outputs are cut in half. And this is what the graph looks like. This is what we call a exponential decay. This is a strictly decreasing function. This is what the graph looks like on the graphing calculator. What is the domain and range of this function? Again, the domain, since we are going to -infinity here, +infinity here, the domain is all real numbers. The range, just as in the last example, are going to be all positive values, because this line approaches, but it never does touch 0. So if you take half of something and keep taking half of it, it's never going to equal 0. So the range is all positive y values, or we can write it parentheses 0, infinity, parentheses. Where is this function increasing? This is a strictly decreasing function. As x gets bigger, y gets smaller. So it's nowhere. Where is this function decreasing? Everywhere, all real numbers. Where is this function positive? For every value of x, the y value, the output, will be positive. So this is all real numbers. And negative, just like before, nowhere. There are no negative values for the y. Lesson objective: base, multiplier property, increase or decreasing property. Property: for an exponential function of the form y equals a b to the x power, if the value of the independent variable increases by 1, the value of the dependent variable is a multiplier of b, the base. For the function f of x equals 2 times 3 to the x, as the value of x increases by 1, the value of y is multiplied by 3. The number will keep getting larger and larger and larger. For the function f of x equals 5 times 3/4 to the x power, as x increases by 1, the value of y is multiplied by 3/4. So the value will be smaller and smaller and smaller as x increases. Let f of x equal a times b to the x power, where a is greater than 0, a positive number. Then, if b is greater than 1, the function is increasing. We say that the function grows exponentially. If b is between 0 and 1, then the function f is decreasing. We say that the function decays exponentially. Now what if b is negative? If b is negative, it is not considered an exponential function. Here we have a graph where the function is growing exponentially. B is greater than 1. And here's a graph where the function decays exponentially. B is between 0 and 1. Y-intercept of an exponential function. Property: for an exponential function of the form y equals a times b to the x power, the y-intercept is 0, a. So whatever value we have here, that value will be the y-intercept. If we don't see a value here, if we have just like 3 to the x, then a is understood to be a 1. Illustration: for the function f of x equals 5 times 8 to the x power, the y-intercept is 0, 5. It is the value of a. For the function f of x equals 4 times 1/7 to the x power, the y-intercept is 4. Thanks for watching.